Welcome to Subaru Ecu Flash Training Part 21. In this video, we're going to be taking a look at working with our spark timing and our knock control within our Subaru ECUs. Now, our spark timing is going to be relation to when we want to fire our spark plug during the auto cycle. It's very specific. We want to be able to achieve proper torque and horsepower production out of the engine. Too low a spark timing will have sluggish performance. Too much spark timing can lead us into knock and pre-ignition, which can damage the engine. So we're going to be learning what spark timing represents, how it's integrated into our Subaru ECU programming, and then also how the knock control works. So the knock control is going to be part of the routine. There's a knock sensor fitted to the engine. If we have knock conditions which can damage the engine, the ECU can make reactive changes to be able to reduce the spark timing, to reduce the cylinder pressure so that we don't damage the engine. So we have to know how they fit together. We're going to be covering all of that in this training tutorial, doing a general overview of how spark timing works between a stock ROM as well as a Carberry enhanced ROM, because there are going to be some fundamental differences of the way that the knock control and the spark timing will work between the ROM types. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at how to calibrate and work with our spark timing and our knock control routine within our 16-bit Subaru applications. We'll find that the way that Subaru has intended the knock control and spark timing to work in conjunction with each other is going to be a little bit different than the way the Carberry ROM is going to be implemented. So in this training tutorial, we're going to take a look at how Subaru has set up the stock knock control logic as well as spark timing. They're integrated, so we have to understand how they both work together. And then we'll look at a Carberry based ROM and understanding the fundamental differences so that whatever ROM we're working with and calibrating, we're going to make sure the engine is going to be safe and we can achieve optimal power and torque production out of our engine. So we have a lot of things to talk about. The first thing that we should discuss is going to be taking a look at and talking about what spark timing actually represents. What does it mean? Because this is something that is a little bit confusing when you're a novice tuner, and it's definitely important to understand these fundamentals and what spark timing actually means. So let's first take a look at our spark timing table in a stock equivalent ROM. So the ROM files I have open here, 2003 WRX. This sample ROM is found in our course packet sample ROM folder. Then I also have a Carberry based ROM. So you can open up either of these to look at in this training tutorial. So I'm looking here in a 2003 WRX stock equivalent ROM file. If we go under the current ROM metadata and we move down here a little bit, we're going to find under ignition timing advanced, we're going to have a table here called base timing. This is where the timing starts from. So it's going to be going from these values that we have in here, and it's altered from the values. So it can either advance or retard from these base spark timing values. But what we're looking at here, what we need to understand the first thing in this video, is taking a look at what this table represents and what the values represent, because it looks like there's just a bunch of random numbers in the table, and understanding how to read this is going to be important so you can calibrate your engine properly. Looking at this, we see that we have engine speed here on the left axis. The top axis is based on engine load, and that's registered in grams per rev from our mass airflow sensor. Now, for equivalence here, just so you understand where you're at and how this table is laid out in terms of your load, if we're looking at 1.0 grams per rev, this lines up to approximately 0 psi or atmospheric pressure, meaning if we're below 1.0, our engine is going to be operating in vacuum. At idle, you're usually pulling about 0.22 to 0.3 grams per rev, give or take. So you'll find you'll idle in this section right here, so 800 to 1200. Now, we do have idle specific spark timing, but just for equivalent sake to kind of conceptually understand where you're at in the table. Now, if you're driving part throttle cruise situations, the spark timing will be coming from your area right here. So essentially from 0.22, which is going to be lift throttle deceleration type of grams per rev load registration, up to about 0.86, this is going to be in vacuum. So this is where the spark timing comes from in part throttle cruise. Once you start to transition into boost, you'll go here and transition across this 1.0 grams per rev range. And then when you get into boost, you'll be here in this column 1.12 and higher. So you'll find that's going to be the general layout of the table, how this works. So as we're driving here, as we're changing our RPM, we can see the spark timing is essentially going to be getting higher as we go up in higher engine speeds. And as we go up here in load, so going here from something like 0.4 grams per rev up to something like 1.4, we can see the spark timing is quite different. Here is 42, 43 degrees of spark timing. Here is going to be 18 degrees of spark timing. So very large difference between these two operation points or zones within the calibration table.
and that's done for a very specific reason. We're trying to offset the increase in cylinder pressure and therefore an increase in rise in cylinder temperature that can lead to knock and pre-ignition conditions in our engine. Now, knock is when we have uncontrolled combustion that can have very rapid rise in cylinder pressure, which will damage the engine. It can break the pistons, break the connecting rods, pound the connecting rod bearings out, score the crankshaft, it could split sleeves, pop a head gasket, all things we want to avoid. So when we're going in and tuning our spark timing here in our table, this is going to be where we're commanding the spark to happen on our compression stroke, and the values in the table are going to be representative of degrees before top dead center. So as the piston's going from bottom dead center, as we're going from our intake stroke to our compression, it's going to be swinging the piston going upwards towards top dead center. The higher the value here, that's degrees before top dead center. So a value of 40, that means we're firing off our spark plug 40 degrees before the piston reaches top dead center on the compression stroke, before it moves into the power stroke. And then if we're going with a lower value, something like 18 degrees, we'll find that's going to be firing off the spark plug closer towards top dead center as the piston's traveling upwards on our compression stroke. So what we're finding here is that we're essentially, as we're going up in boost, we're finding that we're offsetting and reducing when we're firing off the spark plug in terms of the values we represent here in the table to avoid having excess cylinder pressure and going in and having excess cylinder temperature, which leads to knock and pre-ignition. So that's the goal here. Now, just to give you a better visual illustration of what is going on here within these values, let's actually take a look here at a video that's coming up on screen. This will go through the auto cycle. So let's just quickly run through the strokes, and then we'll go back to the point where we're on the compression stroke and moving into the power stroke so we can understand conceptually and visually what these values represent, what we're actually trying to accomplish by moving these values around. So looking here at our video, let's start off. We're on the intake stroke. We can see the intake valve is opening. We're finding our fuel and air mixture is being drawn into the cylinder. The piston is moving downwards towards bottom dead center. Now, once we reach around bottom dead center, the intake valve is going to shut, and we're going to find the piston changes directions, and it's going to move up on our compression stroke. That's where it's going to compress the fuel and air mixture.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.